Yeah, I guess it'll be easier the second time around. And you only have to do that part at least. Okay, nice. Hell yeah. Well, good luck. Um, 2/3 z plus a half to the n. Why are they using m for the index? I guess I'll match it, but like, why m? So we get 2/3 to the m plus 1, z plus a half to the m. Uh, and this is a Taylor series. Hey Eldritch, I will solve the dawn and tell the math factorial the story of me solving dawn. you do that, Eldritch. I have complete faith in you. We're doing well. Um, so I guess this is the answer for part. Oh, well, we need to answer where it's valid. I suppose it's valid. Ooh. You only accept credit cards. I'll, I'll fix that immediately. Check your DMs. I guess we need to require that this thing is less than 1. Huh. That feels kind of weird, but it's what it is. Tis what tis. Um, I'd like to check this some completely different way, if possible, too. Oops. Sounds good, Eldritch. Eep well. -2 less than z less than 1. Does that make sense? Maybe. Maybe not. Hmm. How would we do the if we wanted to avoid using 1 over 1 minus z, what would the strategy be? Oh, Catmaster, that's a good idea. We could plug it into Desmos and see where it blows up. Yeah. We'll do that. Thank you for the suggestion. Let me bring it up. In conclusion, I may need to learn more about math before doing some big non-existent discovery. It definitely helps. Sum n equals 0 to some, we'll call it a. I like I've been trying to think of an area of math that I could like recommend to you because you seem to like thinking about operators. I just don't know enough about like higher level math to like suggest a good thing for you. Desmos, cooperate. To like suggest a an area of math that you should like try studying. Oh, beautiful. Thank you, Catmaster. That looks about right. So I got from -2 to 1. It yeah, I guess. Now I'm trying to figure out if I call something k sub n of f equals y plus y squared plus y cubed dot 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 k sub n of 1 y plus y squared plus y cubed. Oh, okay, so you're going for kind of like a recursive definition. I guess you don't have to make that recursive, but you could also... Oh, of f. Or k1f, k2f. Okay. You know, I might have an idea for the... If we wanted to avoid using 1 over 1 minus z, I think we would start n equals 0. Sorry, m. Wait. Oh, they use n in the first part, but m in the second part. It's funny. Just use n. We start that. Is there like a? I feel like there's a binomial idea, because we can rewrite this as n equals 0 to infinity z plus a half, the thing we want, but then minus a half. A complex number. And so basically, I would want to use the binomial theorem on like that as one unit, and then that as the other unit. We're gonna get a double summation, and I'm just gonna hope that we can simplify that out. 0 to n. So what it's gonna be for binomial. N choose m times z plus a half to the m times minus a half to the n minus m. And what happens here? In the Lambert W function, we to the w equals x, and w of x equals x is the inverse. I don't know much anything about the Lambert W function. Let's see. I never like have really encountered it. I never really like needed it. Why is that multi-valued? W to the W. Hmm. Yes, Mel. W of x equals x is the inverse. Stooky, thank you so much for the raid. Welcome in, people. Hey Jens. I hope your stream was good. I was lurking on it. I saw you were doing you were reading that paper on geometric algebra, which I had never heard before, and just hearing about the existence of that made me a little bit mad because like it's yet another niche of math that I just had never heard of before. I hope it went well though. For all of you who are joining us, I'm allegedly working on homework. I was starting off with this complex analysis question with series, but then Lucas asked a question about the Lambert W function and its inverse. And I never really used the Lambert W function, so I was just trying to like read about it. A good time. That's good to hear. So no problem with algebraic geometry is? Well, no, that's the thing. It was geometric algebra, which is, as I understand it, completely different from algebraic geometry. It is? Okay, okay. Yeah. Oh, Stuki just says good morning. I don't know what the origin of that is, but it's always a good morning when Suki's around. Here's a spot on the inverse. Just tell me the answer, please. Oh. You might be onto something there, Lucas. I'm not sure, though. Why would the inverse be so simple? What a trippy graph that is. Uh, I'm still weirded out by just why this. Where's the multi-valuedness coming from with this? Do you need to write W in polar form? Is that the issue? I know Wikipedia is usually a little too advanced. We can look for another link. You know, we can just cut straight to the chase here and look for inverse. I don't know why that would make it multi-valued. Oh, the Lambert W is the inverse function of that. Okay, okay, that makes way more sense for why it's multi-valued then. Because there's going to be a log somewhere in there. So then, well, then the inverse of the Lambert W is just this function then. I would think. Well, I guess, okay, well, no, that's tricky to say though. Because WE to the W is, I think, single valued, but Lambert W is multi-valued. So you probably have some weird cutting up of the complex plane that you have to do to, and you know, like it's only clean in one direction. The other direction is not clean. You've grown to like it. It's important for something. I don't remember what, but it is like a it has an important place in math. So yeah, I'm not really sure how to answer the question, Lucas. I know I've heard Zach talk about the Lambert W function. I don't know if you would know this offhand, but about the inverse of it. What was my question? Yeah, I think that's it. WE to W, potentially with some weird branch cutting stuff, but yeah, at least it, I definitely feel like the deeper you go into math, the worse the notation gets. Um, Not that like because subject gets so complicated that it's hard to express it simply, and we end up reusing a lot of the same letters for different purposes or stuff like that, and the notation definitely becomes an obstacle at some point. So what's problem on the screen? Okay, let me show part A first. So we're working with just a generic like geometric complex series. They ask where is this analytic, which is, it felt like kind of a trick question, where I feel like the unit disk is just as valid of an answer to this question as is the entire complex plane without -1. I'm going with the second bit, which, I mean, I guess this is the better way. Dude, the C for complex is so annoying to draw. Like, I guess that is my answer there. But I feel like it's just as valid to say the unit circle or the unit disk. But after reading part B, like, I think they're intending for that answer. And so I've done part B in kind of the usual way that isn't too bad, which is writing it in terms of the sum 1 over 1 minus z, and then manipulating it until it looks like it's being expanded about -1/2. But I want to do it the weird way of not using 1 over 1 minus z, which is a tricky and fun exercise to do, apparently. And so my idea for that was to use a binomial expansion. So we start with z to the n, rewrite it as z plus a half minus a half. And then expand it and pray to God that we can get rid of the choose and the minus 1/2 to the n minus m in that summation. So like, really need to hope that we can find a geometric series in this, really. Y to y equals x is too shit to transform. Is it helpful to think about the definition of choose? I don't think so. You choose to not give a fuck. That's a good idea. Don't behave with cold manners. Yeah, you're being really rude there. It really read the root. It did, yeah. Oh shoot, Jens, I read your chat, but I forgot to respond to it. I'd explained to a grad student the other day that equal can mean many different things. Yeah, to be honest, like I don't even know the full explanation of that, although I know that it can mean different things. With or I guess like the example that most people know is the whole 0.999 whatever equals 1. But this equal sign is kind of like deceptive. Like I think what would maybe be less deceptive is to use an arrow, right? Because it's just like approaching 1 in the limit. But then like what does the arrow mean too, I guess. So yeah, I guess that's why we have equivalence for relations, right? Hey, Dija. Distinct numbers have an average, which is also distinct. What number is between those two? Oh. Well, wait, the average of 3, 4, and like, or just like even like 1 plus 2 plus 3 over 3 equals 2, right? But 2 is not distinct from 2. Oh, 2 numbers. Okay, yeah, for 2 numbers, I agree. That's an interesting... I haven't heard that rationale for it. I always heard the geometric series thing. That's kind of neat. Point 0.9 repeating, 1 repeating. Well, you can't have two infinities. Like, you can't have an infinite number of 9s, then an infinite number of 1s after it. What is this number? But also, if you could, then couldn't I say that 0.92 is after that one? Anything is possible in math. That doesn't mean it's correct. You can write anything you want. Division from 9 to 1 takes place at 10 to the minus omega. As an infinity? uh... Yeah, that's still... That would be less than 0.99 repeating though, right? Because now you just have like a... Alright, I don't know. If you have a finite number of 9s, like you have a really large number of 9s, but they still end at some point. So, like you can do that, but that's less than just regular 0.9. Because that's like finite. That has a subreddit, infinite 9. I've never heard of it. Well, let's investigate. This sub is infuriating announcement. Wait, okay, let's read the about. Understand the power of the family of finite numbers, where the set 0.9, 0.99, 0.999 is infinite membered, contain all finite numbers. Meaning for those that understand that the reach, span, range, coverage of these 9s. Sure. So they are in the camp that 0.99 repeating is not 1. I don't know what 10 to the minus omega is. You know, maybe, Lucas. What is SPP? Ten to the minus omega is epsilon factorial? What? Is this a real thing? 10 to the minus omega. Oh. What? Okay. I'm getting a generic exponential graph and body supplements. Or freaking, yeah. Okay. Oh, not just epsilon. Okay. To be a certain. Oh, South Park piano. Okay, yeah. E, there's another possibility I forgot. F, multiple of the what? Oh my god. This is the real rage bait right here. The E isn't the... Oh my god. Okay. So this person is really insistent that 0.99 repeating is not 1. That the people who say that just make this person angry, it seems. What's this post? F is just E plus 1 because that's how the alphabet works. I mean, that's okay. I was just mad because he said E, but like E is an option, but there wasn't an actual option. I don't know what I don't know, but what I do know is that I don't know. 0.9 plus epsilon equals 1. There we go. No. Yes minus epsilon. Oh my god. All right. I think that's enough of that subreddit. Wait. Oh, I didn't see if something was tossed or not, but now is the time to go ahead and pursue that love interest. Oh. Oh, that's what you mean was no. That just means like dating, not anything dirty. Oh, I think it's 13. Like, as far as I know, that's like you have to be 13 to be on Twitch. There are known knowns and there are known unknowns, but there are also unknown unknowns. That's true. I think so. I watched a video once that was called like the 12 incident, where this big WoW streamer, his entire chat, like so someone mentioned they got banned for joking that they were 12, and then everyone in chat started spamming that they were 12, and Twitch banned all of them unless they submitted their like an actual like government ID to Twitch. I think it's like an automatic like detection software. So you should not joke about being under 12 unless you want to give Twitch your ID. I don't know what to do with this series. I wonder if it's better to write out actual terms. Oh no, this isn't accurate. I need the chooses. That dude, if this thing just wasn't here, I feel like life would be a lot better. There are no known knowns because to know no knowns are unknown. You have to know knowing the sure. Whatever that means. Yeah, Mega. So I already did it. This is like the entire context. And so I did it the way that you probably should do it, just by going to 1 over z and manipulating that. I wanted to, like, they gave that hint that you could do it without using 1 over 1 minus z though. And I want to see if I can figure that out. But I'm kind of stuck with that, so I might just move on, but... One can know the unknown if and only if they can find a way into it. Ooh, that's a cool quote. That makes you think of, like, black holes. Oh, is that from Frozen? Into the unknown. I haven't watched Frozen, but I'm sure that being a dad, you've watched it at least 1,000,000 times. So yeah, if it's not binomial expansion, I really don't know what else you would really do. But I can't figure out the binomial expansion, so... Yeah, I'll probably just move on. It'd be cool to figure that out, but it's not the end of the world. Color cone, thank you, thank you. Right back at you. Yeah, there we go. I was about to type that. Oh yeah, I did come up with an answer to the one that we were thinking about the last time I streamed with a non-analytic even or an even function with a singularity at z equals 0. Actually, I have 2 ideas to do it now. I didn't use it, but I think it's possible to prove that the integral of an even function is odd. And from there, you can just, like, use the unit circle and you get... or you can show that it's equivalent... Instead of integrating over the unit circle, it's equivalent to integrate over the upper half of the unit circle. And then you end up with just, like, an endpoint on one end of the unit circle, another endpoint on the other end of the unit circle, and they cancel because it's odd. That'll take a bit more justification than I cared to do, but I think that will be valid. The one I ended up going with is, after thinking a lot about the z equals minus u sub, I am pretty sure that this would reflect our contour across the origin. But then because it's an even function, we could freely flip it back, importantly. And so I ended up with f of z dz equals minus c f of u du. And then I just renamed u back to z, which I'm like 99% sure is okay, but always feels sketchy. And then you can just add this to the other side and then divide out the two. Problem is that, oh yeah, hey, Smooth Space Odyssey, hope you're doing well. Problem is that primitive may not be well defined because your integral may be path dependent. What is the primitive here? Or I don't know what primitive actually means. I am kind of glazing over that. Like, it does seem a little weird to say that the unit circle will be the same as the upper half of the unit circle when, like, if you're thinking about it in terms of deforming, you would be passing through a singularity, which is bad. But I was kind of glazing over that, I guess. If I tried that line in bar, come back to my place, so I can reflect your contour across the origin. You know, I should try that. I'm alright. Tried to submit a paper in archive, and it said no. Oh, that sucks. Meant for the other approach, primitive means integral of a function. Oh, okay. You see the integral of an even function is odd. Oh, yes. That is a good point. Yeah, I was hoping that being analytic everywhere else would justify that, but it is. I don't feel entirely comfortable with that because of the singularity at 0, of course. But yeah, so I was going to include this picture here, but at least for justifications I am going with like reflecting it back and forth. But this is just, I don't know, it felt like a little bit too much. Because I also wanted to justify that the orientation stays the same with these reflections. Because if it didn't stay the same, we'd have problems with the sign. Is able to keep minus 1 over z's derivative is supposed to be log of z. Yeah, I saw that somewhere on a Stack Exchange thread. Which is, that's just a really annoying like thing. Like, can we just let it be well defined? Oh yeah, I get what you mean. Oh wait. Yeah, okay, so whenever z is an odd function, right? It's now log. I would not think of. I guess you could say log, just in terms of actually. Okay, let me just speak in terms of real numbers at first. Whenever x is odd, I guess the integral, the primitive absolute value of x, that's even. But you need the absolute value. If I just ignore branch cuts, what happens if I plug in log of minus c? I'm just kind of curious, like, does log have symmetry in the complex plane? Well, yeah, I guess it's almost like we could write that as like 3 pi also. There's like two sources of multi-valuedness here. Right, there is no absolute value. I remember getting tricked by that at one point, and so I feel like I'm good at remembering it now. I forgot the 2k pi. Or 2n pi, I guess. So this is different. So I I think that what we're seeing here um that's weird. So log is not even in the complex plane. Because this is always an odd multiple of pi. This is always an even multiple of pi. So they're never the same. That's kind of weird. So I was wondering if we could still like save the statement that the primitive of an odd function is even, or vice versa, if we just restrict it to a particular branch, but that's not even true. It's just not. There just isn't the symmetry here. For scale a function odd, then you say it's weird. I'm being very pejorative. I am. This function sucks. Fu function. um yeah, Territar, we're actually like just talking about that. So I can even just show the actual LaTeX that I wrote too. Um, that's probably a little bit hard to read on stream. But so I use a u sub z equals minus u, and I did it for an arbitrary contour, and my idea was that that u sub would reflect the contour across the origin. But then because it's an even function, we can freely flip the contour right back across the origin, and the orientation stays the same. So with that justification, I ended up with this right here. Just that the integral of f of z is equal to negative the integral f of u. But then and then I just renamed u into z because it's not any different than this integral over here, and they can add it to each side and divide by 2. Hey, Lobster. Hope you're doing well. In the theory of quadratic form of the integers, there's this funny terminology. Q is even if for all x, q of x comma x is an even integer. Huh. Okay. And odd is just not even, which is weird, but okay. If q is odd, does q of x be... It sounds like it can be. It's just not even for all x. Hey, Adia. That's super weird color cone. Q of 0, 0 is always 0. Oh, yeah, fair. But yeah, Territor, I did have a secondary idea, which is trying to say something about the integral of an even function being odd, and then using the unit circle as a particular choice of curve, and you can get like 1 point on one end of the circle, another point on the other end of the circle. But that's potentially sketchy, and it takes a lot of work to build that up. Hey, Zach. All right, Adia, sleep well. Thanks for saying hi. How are the classes going? They're going well. The complex analysis class is moving really fast. Like we're already doing residue theorem. With this book that the class is sort of following. We're already on chapter... we're on chapter 4. After 3 weeks. So I'm really glad that I did all the studying over summer, but I'm also nervous that like I needed to do even more. Makes a certain amount of sense because an integer valued function can be multiplied by 2, gives something where all inputs lead to even outputs. Saying odd means not even isn't terrible. Okay, fair enough. Oh no, I really like all of my professors. The one who teaches this class for complex analysis, I really like the way that he explains things. He only loosely follows this book. He really has some or he's written like an unpublished super short complex analysis book. And he has a bunch of like lecture notes that are things he actually follows from during class. So yeah, he's definitely not just like reciting the book, which I'm glad. And you have a very sick issue with grad teachers? Oh, I'd be like with grad teachers that do that, or is there like something more? He does have a really funny way of explaining multi-valued functions. Like it was more like it was really early on in the class. He asked us, what do you do with a multi-valued function? And he like he waited for a few students to give responses and stuff, and eventually he said the right answer is refuse to work on it because it's not well defined. And I don't know, just the way he said it was just really funny. But and then he also added the caveat, unless you're the one who created the problem. Put in the brig with a drunken sailor. Yeah. And then he made like a callback to that joke because branch points came up just the other day. So he wrote a few definitions for branch points, and then at the end he wrote our definition for branch points. Refuse to work on it. That's been like the mantra for like certain things. Like we're just not gonna deal with that. You don't even have a clue. Oh my god, Zach. I had a teacher in grad school essentially just read from Rudin's real and complex analysis. It was one of the better classes. Interesting. I mean, Rudens is a highly regarded book, as far as I've heard. But I don't know if I guess you can do that, right? I'm bringing in part C to this problem. Because like we were talking about even and odd functions, and then Colorcomb brought up a really weird definition for even and odd with quadratic forms. That's where that came from. Ooh, we need a computer for this part of the problem. Yay, famished. A computer. How many terms do you need to approximate the value of f of z? Well, okay, with which series? Both of them? Or just one? Also, can't you do this by hand? I, like with Taylor's theorem or something? Never heard that before in pure math. Like, there's a way to bound the error. Hopkins Engineering Program for Professionals advertised it was for people who worked all the time, was taught by non-professor professionals from the Applied Physics Lab. I was not impressed with their teaching, and that it wasn't teaching, it was instructing. Interesting. It's like, on the surface, that sounds kind of appealing, but if... maybe the people that they hired weren't too, like, into the theory of teaching. Definitely bounded for your true-spirited analysis. I would not call myself a true-spirited analyst. Many of them read directly from the text as an instructional method. Oh, that's just terrible. Yeah, Famish, I started a master's in applied math a few weeks ago. And so, yeah, my streams have been homework unless someone asks me a question, and then I will answer their question. Yeah, it's been really cool so far. Lagrange. Oh, wait, that's the proper one, right? Lagrange remainder formula. That I remember that was like a that sticks out of my brain as one of the things I understood the least from that class. Plunder didn't submit the wrong homework for the wrong class. You did? Or was that is done a typo for Don? What career am I hoping to get out of it? No career in particular, to be honest. I'm just doing it because I like it. You did it. Oh no, that sucks, syntax. I was able to pronounce Arzella Ascoli right the first time. It's like Prince Arthur pulling the sword for analysis. Um, This seems cool. It seems like way too many letters for one theorem. Oh, okay. And so this thing, right, this you do the mean value theorem on this thing, right? To bound it, or extreme value theorem. One of those two things. Yeah, let's see if we can do it by hand. I'm also just taking it at face value that it's the same in complex numbers, which basically everything has been so far. I've seen PhD defense people misspelling the name of that theorem so many times. Oh no! First time I heard about Arzela-Arscoli theorem, when I was taking functional analysis, the professor said, by the way, you'll need to know this theorem for tomorrow's test? Oh no! All but one person failed it. Tomorrow, that's a brutal statement there. Oh, you know what? The way that the professor's been explaining complex series is really cool too. With just how much better series are in complex numbers versus real numbers. Like all you need to do is worry about, or is it figure out where the singularities are, and then you know the radius of convergence versus having to know like 8 different tests, whatever you've learned in Calc 2. You have courses to catch up on. Good luck, famished. We're seeing the Arzela-Arscoli theorem, the associated concept about equicontinuity. When I was doing my dissertation, came up way too often on qualifying exams. Be warned, because I don't fully understand. Huh. My master's thesis advisor called all the theorem about characteristic compactness here as Arzela-Arscoli theorem. Oh no. So it's learning myself. Okay, I looked it up on Color Code, but mentioned it the other day. I don't remember what it said though. Arzela-Arscoli theorem. Every sequence of a given family of real-valued continuous functions defined on a closed and bounded interval has a uniformly convergent subsequence? That's not just a given? Is it not necessarily uniform? Is that the issue? None of us has ever mentioned it? Wow. So you know you have Rn, a subset is compact. For Rn, a subset is compact if and only if it's closed and bounded. Yes, I've heard that. Yeah, like this is the annoying version of the similar result for sequences. Longest proof we did? Oh, really? I don't remember. We definitely talked about this when Zach did the real analysis class. I think the first edition of it. I don't remember it being painful. I don't remember how it went though. The main condition is the equicontinuity of the family of functions. Oh, it comes up for the Peano existence theorem. Never heard of Montel's theorem or Peter-Weil theorem. That's like the same thing for the subnorm over a compact domain. A subset is compact if and only if it's closed, bounded, and equicontinuity. Huh. Okay, is subnorm, is that supremum norm? And norm is like, is that maybe like the maximum value of a function? Okay. So called the L infinity norm. Okay. It's because you block out traumatic experiences. True, Mega. Maybe that's it. Proving all Cauchy sequences were convergent was the longest, but you could actually use this to make that proof way easier. So the little professor wanted to do it the hard way. Oh yeah, I remember. I did I think I proved the opposite direction, that convergent sequences are Cauchy. And I was trying to do the other direction, if Cauchy sequences are convergent. And even Zach came into chat and warned me, like, this one is really, like, difficult. You might want to move on. And I was like, you know, I believe you. You look at maximum continuous function on a compact domain, let's say 0 to 1. Okay, okay. Montel theorem, it's about Cauchy theorem, and Arzello-Scully theorem having a baby. Family of holomorphic functions is normal. Yeah, I really hate abnormal families of functions. Oh, okay. You know, I see topology and I just want to tap out. The informals means that the functions in there. Okay. I wish my family was automatically a normal family. Okay, this is gonna be the classic Wikipedia rabbit hole of like clicking on terms, just have to click on more terms, just have to click on more terms. It's actually not that hard if you know this. Prove Cauchy sequences are bounded. Use this and prove if one sequence, subsequence of Cauchy sequence converges, then all do. Hmm. Okay, fair enough. Montel theorem is used to show that the Riemann mopping theorem, which is kind of the final boss of classical complex analysis. Oh, okay, okay. One more hyperlink, bro. Trust. Yeah. That'll unlock all the knowledge of what we've gone through. Just one more. Pre-compact. It's relatively compact. Oh my god. Pass. Never seen a proof of the Riemann mapping theorem. Dude, that has to be like one of the worst names in terms of just like the way it sounds. I want to say Riemann mopping so bad. Riemann mocking? Riemann mapping. Riemann mapping. Riemann. It's just the A's twice in a row pronounced differently just messes with my brain. Okay, so what we want to do is bound f of 0.9 minus some j equals 0 to the n f j. So I'm still confused on whether we're expanding about minus a half or 0. I assume we're just doing both. The question doesn't really say that, but we'll start with 0. Surely one that's expanding about 0 is going to converge faster, right? When you hear about the unique New York rubber baby buggy bumper theory. I think one of the worst ones is Irish wristwatch. Actually, that was pretty good. Irish wristwatch. Irish wristwatch. Irish wristwatch. Irish wrist. Okay, yeah. No, he's just saying a tongue twister. Unique New York rubber baby buggy bumper. Unique New York rubber baby buggy bumper. Because the US refuses to use diacritical marks. I guess we would benefit from some extra, like, characters. Lagrange error bound is one of those things given to calculations with no explanation. Usually, yeah. These questions are always so weird. Like, we're even just talking about this in my scientific computing class. And like someone asked a question about it, and he was like, the person was just kind of saying like, oh, mean value theorem, and then like that was kind of like the entire explanation. It's like, I feel like we're kind of glazing over it. Hey, K-Pars. Red leather, yellow leather. Red leather, yellow leather. Red, yellow, leather. That is a hard one. Oh my god, it doesn't look hard. Red, yellow leather. Fuck. Red leather, yellow leather. Why is that so hard? Red leather, yellow leather. Red leather, yellow leather. Red leather. That's a good one. I never heard that one. I made one for my family. Sharky, the snarky shark, signed sharks shirts with a shark's sharpie. Oh my god. Constellation boots? How do you say that? Boots? That's what I want to say. Boates? Boatees nuts? Sorry. Okay, but like the German O with the umlaut, I feel like English speakers can't agree on how that's pronounced. Because at least for like girdle, I've heard so many different ways to pronounce the O there. Ran into a video where a Scottish person said that he was told Scottish people couldn't say purple burglar alarm. I've seen that one. Yeah, that's a really funny one. Red leather, yellow leather is still easier than the lyrics to yellow lead better. I haven't heard that one. San Jose Sharks. Yeah, I went to a Sharks game as a kid. Because some friends of mine would always get season tickets. I think they even just got like a spare one so they could like bring people. What is Boortes? I'm not. Herdsman or plowman? You have to really use your imagination with constellations, I've seen. Americans not being able to pronounce donor. Pronouncing a perfect O in Berlin. Oh, how yeah, how would you properly say donor? I think we all just say donor. Is there an O? Is there an O in Berlin in the actual spelling? Diener? You finally found nothing you can mathematically? Nice, Lucas. Berlin? Huh. I guess we just spell it with an ER, I guess. Bar, boots with the fur. Less UE. More like I can get, more like, dinner. Dinner. Der. Der. Okay. Uh, get drink some water. Okay, I have to be real with you guys. I'm wearing two jackets right now because I was just cold, but now I'm hot. So the outer jacket is coming off. For every sub, I take off one article of clothing. Challenge. English, not American, down to Austria is written umlaut Österreich. I'm just gonna have to take your word for it. New operator because I'm also original, such that of x plus x squared plus x cubed equals a. Okay, sure. Burger pulls out coefficients and does that infinitely many times that the coefficients surrounding x degrees. It seems like it's putting in coefficients. I'm not sure what the second part of that means either. Wearing two jackets is so hot right now. I haven't actually seen Zoolander. How do you solve for n with this? I mean, I guess we know what f is. Solving by not solving for x. Thank you. Doesn't Paul have a thing on this? Give me Paul. Also, I keep telling myself I need to make a Paul emote, and I keep not doing it. Paul will not save you in grad school. He really won't, unfortunately. But you know, I respect Paul. I wouldn't ask too much of him. Actually, he might be about to save me right now. Paul the Pog, Polymote or Polymote, Polymote. Jam pulling into maths is less and less off. Take a break, focus on other stuff. Sounds good, Lucas. Breaks are good. Hey Art, I'm good. How about you? For proving the Lagrange error bound, you can note the remainder of a kth degree Taylor series of f. It's the k plus 1th integral, the k plus 1th derivative of f. Would that help us with the factorial bit? Question mark? Oh, you've seen this page? Paul is great. He might not be great for this though. I swear he has a thing on this. Ah, fuck it. Maybe. I didn't know there was an integral form. By extreme value theorem, there's a C and AX. Right, I remember that being the idea. I so rarely have to actually do this. I forget it every time. Is there a secret website where tests/exams are posted? Not that I'm aware of. No. That is an aggressive no. Color Cone was yelling at us. It is a good emote, yeah. So yeah, like we would use this is the same formula that I wrote on the thing, right? But I want to find k is the issue. A bit lower? Okay. But like well, I don't know what k is the issue. I want to find k. Oh, okay, use a computer for that part. That's fair. Yeah, I just thought that I mean, what was my plan? Oh yeah, my plan was to actually just compute the value. I mean, the value is what, 10? And I could just compute more and more terms of the series until I'm within the tolerance, was my thought. I think I was just trying to figure out how you would do it on paper. That was the point of bringing in the theorem here, but if I'm just gonna go straight to coding anyway, then I feel like I don't even need that. Hello. Oh yeah, and if anyone saw me being extremely confused and stupid with my biology homework last stream, I figured out the issue, and it was really stupid. I was making a really dumb mistake. You would just compute the derivative of your function, get the expression that you need. Yeah, I don't know. Actually, how am I gonna numerically get the derivative? Wait, okay, so let me I want to get rid of this. What I want f is z 1 over 1 minus z. Yeah, that's what I was about to do. F prime of z is, we're getting two negatives, right? So 1 over 1 minus z squared, I think. Yeah. So double prime. Okay, so this is pretty simple. No, I'm sorry, two. Ah. Well, there's two negatives. There's a negative from the power rule and then another negative from the chain rule. So I think this is our general form of the derivative. That's pretty easy to program. Right? It's not valid for n equals 0. Wait, factorial! Okay, there we go. Wait. No, it's just n. Okay, there we go. I don't think you remember the channel name. There we go. Wait. There we go. That makes more sense. I always get tripped up with this being the 0th derivative. This is good now. This really isn't a complex number problem, I feel like, because I'm glad it's not, because that'll make it harder, but put z equal to 1 here? Or like, oh, z equal to 0. Okay, yeah. Yeah, Stefan, this is like, we're basically just doing a regular Taylor series now. This is in the context of something that's harder, but we're doing Taylor series. Why did I need the derivative? Don't we already know what the series looks like? Wait, yeah, why am I doing all this? We already... Wait. We already know what the series is, right? For science. I think I still have a volcano doc gift sub. Let me see. Yeah. Isn't there another one? I don't know. Because I need the integral? I don't think I do. I think I can just do the absolute value of 1 over 1 minus 0.9 minus n equals 0 to infinity. What is z? It's a 0.9? Yes, it is. And it, sorry, not infinity, but like a or something, and keep increasing a by 1 until we have something that's less than 10 to the minus 6. Because I can do this term by term. And I can do the same thing for the other series that I computed too. That's about minus 1/2. I think that's the simplest thing. Doesn't that defeat the purpose? I don't think so. I mean, we can just evaluate it directly. So like we would need the integral thing. I know, but like it's just 10, right? Like it's so easy. Like I feel like why would I not use it? This is such a weird, like we haven't talked about this in class. Like we've been talking about series in class, but like I don't know why we're doing a problem like this. What is the, okay, wait. It might be what are the next two parts? What? Next Monday. What does this even mean? Wait. Well, yeah, I know, but like, okay, wait. So I've been confused with part C on which, on if they mean F or G, but I guess they mean F. F of Z and Z equals 0.9. Okay. So why would we use, this is a different series for G though. We could just do it, but like it's not going to be as accurate. I don't know what the hint means, I guess. That's what I was really like. With this value, We don't need approximate values. We know the exact representation. It's the hint that's really confusing to me, I guess. Like, we don't we found what it is. That was the entire point of part B. I don't get what they want me to understand with this problem. Okay, I think I know like what to do. I'm not really happy about it. I need to rename this folder. It's bothering me. I need a new folder. No, not in that. Okay, fine. No, oh, this is a file? Oh my god. Bruh. I need to get good at clicking the right button. No, don't. Ah. Yes. Okay. Good. Homework 2-3.py. Okay. There we go. Get good. I need to, Zach. What do I want for this? I don't know. Def fun z return 1/1 minus z. Code for homework 2 exercise 3c. Def series cn return z to the n, right? I'm just like keeping things like this is kind of overkill, but just to keep the code like a little more like generic, I guess, like applicable to other situations if I cared to do it with another function in another series. I equals 0 while is it ABS in Python? ABS exact val minus is greater than, I guess, or equal to, but it doesn't really matter. Tolerance equals 1e minus 6. Okay. Series sum plus equals series z not I plus equal. Also, why can't I do I++ in Python? I++ is so nice. There's nothing wrong with it, but Python doesn't like it. Approximation. Series sum. Iterations. I. That should be everything we really need. Not bad. 153 iterations. That's a lot of iterations. Oh, you know, it's probably hard to read on stream, isn't it? Okay, well, 153. Part D. Now, I assume we're going to code this. Surely, like, the entire rest of the problem is coding. Or was this hint about not using coding? Also, the parentheses are mismatched. Wait, you know what? I just want to be sure. They have pulled a switcheroo on us before where they publish corrections to the homework. And they announced it one time, but then they published 2 more corrections and didn't say anything the next 2 times. Let me just do a quick check to make sure there weren't corrections. Okay, no. They haven't updated it seems. Use the value of n in the previous part to compute. I'm just gonna code it. I really don't know what they want me to do with this. Like, why would we approximate values for C sub n? Oh, that's not the right screen. Maybe I should call this series 0. Oh, there's no way you can have slash in a function definition, right? Half. Return, and then what was the definition, or what was the thing that I found? It was 2/3 to the n plus 1 times z plus 1/2 to the n. Yes. Excuse me. Now compute value with same terms. About 1/2. Was -1/2, right? For I in range. Oh, well. I was a poor choice of names. N is clearly a superior choice. For I in range N, series sum half equals 0. Series sum half plus equals series half z naught I. Print f approximation about z equals -1/2. Series sum half. It's less accurate, but still pretty close. I'm kind of shocked that this class gave me a coding problem. My other two classes are like 90% coding, so I expect it from them. But this class, I did not think they would call for code. At least it's like simple code, though. I told you class you were here and tell me once? Only once. Yeah, I mean, I don't really know much about topology, so I don't know when it might be helpful, but I guess maybe for like some type of like visualization. That's problem. I really don't understand what they want me to learn by doing this. C1 equals -1.1. Ah. For I in range N. Series sum half 0. Series sum half 0. Series sum half 0. Series sum half 1 equals 0. Series sum half 1 plus equals series half z1 I. Print f approximation of g of minus 1. Actually, I can be fancy. Z1 about z equals -1/2. Series sum half 1. Four 4761904. 47619. I thought they were going to be different. This is the exact answer that like you would expect reasonably. I thought I was going to be surprised here. Like, explain my results. It turns out that series converge inside of their disk of convergence. Is that what they want me to explain? Okay, I really don't understand what they are trying to do with this problem. But we can just push forward. Okay, LaTeX time. While slash sum n equals 0 to infinity. Okay, you know what? This is really annoying me with LaTeX. Let me just compile it so it's easier for you to see it. When they do summation, the bounds go above and below the sigma. When I do summation, it goes to the side. Now I know I can do slash limits, but like I don't see the difference between what they did 2 lines above and what I did right there. Oh, double dollar sign? Oh my god. I have only learned LaTeX by doing. I don't know any of the theory. So that's gonna make it onto a new line, right? Yeah. Alright, fine. I'll just do slash limits like a pleb. Z to the n. Oop. Converges for z slash leq1. Oh, absolute. Oh, by the way, Don, I'm in 2 weeks. I should do a week of stream with Slim on Topos theory and logic. If you want to join. Oh yeah, so I saw you talking to Slim about that, and I thought it was about topology, which is like, oh, you know, it if they're willing to do like basic stuff, then maybe it could be cool to get introduced to it. But topos is like a category theory thing, isn't it? That I don't think I'd want to join for. The category theory is way beyond me. Also, slash every math slash display style. Putting that before slash begin document like every math thing display style. Oh, okay. I don't know if I would want that, but that's good to know. Um, it come from geometry has a category theory taste. Oh, okay. Yeah, that's good to know, Zach. I guess I wouldn't like that it would always put it on a new line. Is the issue with like display style? Um, it won't? Oh, okay. Fair enough. First stream, we'll just talk motivation-based stuff. You might be able to learn a thing or two. Uh, I mean, I guess I could be interested in that then. It depends on like if I'll have time with the like the grad school stuff. But if you want to like send me some stuff about it, or like once you know what the plan is, like let me know. Like uh, it could it could be interesting to at least like learn the first thing about it. Yes, sounds good. Oh no. Oh, where did I scroll? Okay. Is equal to slash frac 1 minus z. Just analytic everywhere except at z equals 1. This still makes me uncomfortable that the series converges only for that, but the function is analytic everywhere except at a point. Now, okay, the title of this is Analytic Continuation. Which maybe that's what they're trying to get at here. But like, why don't they make us do an analytic continuation down here? Oh my, okay. I'm sorry, this homework is just so weird to me. Or like, this problem is weird. Like, I would love to learn everything I can from this problem, and I feel like this is, like, I don't know. This just doesn't feel like a problem where I'm learning a lot from it. What do we have here? Okay, I'll keep this. Take a deep breath. Oh my god. No, see, this has stuff like this has the opposite effect on me, where I feel like someone is telling me to like be calm when I'm not that angry, and that just like makes me mad. um, no, I'm not actually that mad. Me yelling at the homework that I'm currently doing is a thing I've been doing. Well, I mean, I haven't done it recently because I haven't been in school for a long time, but uh, even when I was on streaming, I would yell at my homework because it's sometimes just like annoying. This time we'll do display mode for part B. F of z equals slash frac 1 or 1 minus z. So like it's kind of weird that they say like g of z equals f of z, right? Well, it's subtle. Let's just not include the f of z. So what I did here, I said 1 is equal to 3 over 2 minus slash frac 1/2 minus z. Oh, I forgot the first part of the frac. Which equals slash frac 1 slash frac 3 2 minus z plus slash frac 1/2. Which equals slash frac. There's a lot of fracking happening right now. Slash frac 3 2. 1 minus slash frac 2/3 z plus slash frac. Oh my god. Ugh. There. This isn't... I just want to see how this looks. Hey, Sockno. Think of a way of putting my chart for the profiles in a more simplified design / format. Ooh, nice, nice. You love to hear it. So the profiles so you can get in one block. Okay. I want to do one more stage of fracking. Just to flip that fraction. The rest of this can get copy pasted. Okay. Now, slash sum. This is a really long chain of equalities. M equals 0 to infinity. Oops, I need my... Actually, it's fine. Fraction. I need my slash left slash right to the m plus 1 z plus slash frac 1/2. I need slash right slash left to the m. How do you look now? Looking good. I guess we should explicitly... Okay, so like this is C sub m right here. I guess... I feel like I shouldn't have to, but we'll explicitly state it. Slash left slash frac. I'd really rather not lose points for stupid stuff, so I with all my homework, I've been erring on the side of explaining too much rather than too little. Take you and modify you. Slash sum slash limits. Actually, I do want that slash left. Wait. I'm getting lost in the latex sauce. Slash right. Okay, that's good. It's a lot of parentheses. I think I need them all, though. Do I? Yes, I do. Wait, they're mismatched. Why isn't it yelling at me for... Oh, because I have... There. And set slash frac 2/3 z. I should really just be copy and pasting this. Less than 1 absolute value. Slash left slash right. Okay. Checking again. Wait, what? Does slash left not work with bar? Oh, I just don't know how. Oh my god. Bruh. There we go. So, -2 is less than. Oh, I didn't check the endpoints. Oh, would I get dinged for not checking endpoints? Oh, that's like a classic like Calc 2 mistake. It's a geometric series. The endpoints usually don't work, right? Ugh. -2 plus a half. I think the endpoints never work for geometric series. Yeah, so that doesn't work. 1 plus a half. Okay, yeah. So neither of the endpoints work. It's probably. I should probably mention that. Just to give a shout out that like I did think about that. Essentially, if you were to look at rated voting or score voting, it is like Connect 4, but each person putting their own chips, which so no matter how you form matrices of voting options, there will always be the secret dictator, Duncan Black. I find understands this principle. However, his reforms end up in a Bayesian paradox socially. What is that? A Bayesian? Well, I don't know what this is, but it's the first thing that came up. Yeah, sure. Different results for certain choices of the prior distribution. Huh. Yeah, let's wait to see what your link is, because it might be a completely different thing. Brace paradox. Doing one or more roads to road network. Oh, I've heard of this one. Yes. There's a Veritasium video about this. It's like a graph theory thing. So let me reread your comment now. Essentially, if you were to look at rated voting or score voting, it is like Connect Four. Person putting their own chip switch, no matter how you form matrices of voting options, there will always be the secret dictator. Blackify understands this principle. Forms end up being an embrace paradox socially. Really? So how would this paradox, or how would this paradox like happen with voting? Is it like giving people more chips to rank candidates doesn't always like increase their ability to express their opinion, I guess. What is FBA? Oh. This Wikipedia page is a little thin, but fair enough. Yeah, sure. I mean, okay, so for the coding section, LaTeX has code blocks, right? I feel like I saw a button for a code block somewhere in Overleaf. Overleaf code block. The thing I might like most about math is that I'm starting to understand the funky notation business. Oh, good. Median voter theorem? Okay. Just kind of speed reading this. Might be not less important. Some awkward phrasing. Have to manipulate the median voter to either side of the political line. That's fair, yeah. And that's like the dictator paradox that I thought the paradox that you just brought up. That's a paradox we've talked about before, or I was like, maybe it wasn't called a paradox, but like that's like you can consider that median voter is like a dictator because only their vote really matters. Hmm. And so the thing with Brace's paradox would be that like as soon as giving people more like kind of like tokens or chips, as you say, doesn't solve this secret dictator problem. If you remove the median voter political platform, it ends up in a Brace inefficient model. Oh, okay, that's what you're saying that the Brace paradox is. Huh. I guess as in like it'll just be like gridlock without the median voter and nothing would ever get done. I guess I need to get I never had to do a package in latex. Can I just copy paste this? I assume somewhere at the top. Okay, yeah, this looks like the place to do it. Then I can do /begin list listing or learning things. Slash. Oh wait. What was it? Oh, it is /end. Why are you angry with me? I did everything that you asked. Does it not like the package? No. I copy pasted it. LST listing. Oh, ha. I don't know how that got there. Need to practice more series? You've come to the right place, Mouse. We were just doing some series. Yeah, this is just like a regular geometric series. Like this isn't much of a complex problem, but we are technically using complex numbers. I also think from this that this correlation doesn't mean causation because it doesn't only apply to a left-right direction. It can be any bias. Yeah, I mean, I imagine that political theory doesn't. I mean, do they talk about left to right bias specifically? I would imagine that they don't, they just kind of go directly to or they speak more abstractly about like two sides of an issue. I sure hope it's that this is enough of an answer for A. I won't know until I get my grade, I guess. That's what I'm planning to turn in, unless I think of something else, though. Um, actually, should I do my entire thing of code at the end? I think that's better. I should do. I think I stick my code on at the end here. Oh, we have the same course number? 567? That's funny. Should I? Ooh. Just the content? Oh, okay, okay. Um, individual terms of series expansion. The more ramble in the current US system, that is where they are playing their fits. That is Duncan's hint. Okay, yeah, that's fair enough, I guess. I could send you the PDF of the problems, yeah? Where do I have them? There they are. I think it's gonna end up being more in any system though, because if you just end up in contradictions, yeah, there would be a central focal point of a society. Yeah, I feel like you shouldn't have to care about this specific type of like divide. Okay. How does this look? Kind of disgusting, but this is the right syntax highlighting. What is this font? Okay. I think I did it right, but I'm not happy about it. When I mean contradiction, I mean political value x and y will happen under the system is given. Oh, okay, fair, fair. Do you often use 2 pi I over n factorial fn z naught for the integral? No, my professor actually specifically said that the Cauchy integral formula for derivatives is almost never used for like practical purposes. It's helpful for proving that an analytic function has derivatives of any order. Like you can keep on taking derivatives as many times as you want, but that's like the only thing it's really helpful for showing. To use cylindrical coordinates because of the generalized what? What would cylindrical coordinates be in complex numbers? Oh no, sorry, you're responding to color cones thing. That's for another class, I bet. Use it for computing the residue of higher poles. Isn't the residue always with the -1 power? I mean, but like if you do have an integral with like a power in the denominator, you could use it. You could use it to do that, I guess. Like if you have a sine of z over, yeah, okay, yeah, that's fair enough. Color cone, yeah. We use other techniques like the Cauchy residue. Usually, yeah. If you do have something like sine of z over like z to the fourth to the 4, though, you could use that formula. Um, yeah, I guess that's fair enough. Good enough for me. Uh, 1 over z to the fourth should be something around 3 over 2 pi I. Well, we have to say what the contour is. Because if the contour is just like the unit circle, it's only not analytic at z equals 4. So the contour has to be around 4, I guess. It'll be some multiple of 2 pi I, probably. Or will it? It might just be 0. That's such a complex analysis answer. No, if it's just 1 in the numerator, Don't don't you get 0? Yeah. Uh, Sakno says, yeah, like someone will believe chocolate ice cream is better than vanilla ice cream and vice versa. There are so many types of chocolate, some that cause controversy, like white chocolate, 92% dark chocolate. We have different textures of chocolate. Some desire to have chocolate chips and vanilla ice cream. They mean it's vanilla or chocolate. Ooh, that's a good question. Yeah, in terms of like how contradictions can enter into like a system. I'm the new Bernard Freeman because I said it's some multiple of 2 pi I. I feel like it's a pretty safe answer when it comes to complex analysis. So if you do the integral 1 over z to the 4th minus 4, I think this is 0, even if you're enclosing 4. Yeah. The only time you don't get 0. Now, if you change the numerator to be like, you know, sine or whatever, you're not gonna get 0. But if the numerator is 1, I think you just get 0. Yeah. Please don't die at 39. No promises. Yeah, and so if you were to apply the integral formula for derivatives, you would take the derivative of 1 and get 0, right? No, I'm 28. I didn't know that, but I guess Riemann died at 39. You're older than me, Mouse. So if I'm old, you're ancient. Yeah, I didn't know that he died that early. Ooh, that's a good beard. Dude, I keep saying it, but there needs to be a stream that happens one day where we power rank mathematicians' beards. It just needs it to happen. Mice age makes me younger. It's like dog years, but mouse years. Hey, Puika. And still be a genius. It's nuts. Yeah, that he accomplished a lot for such a short time. Don't tell Zach, but Riemann greater than Euler. Wow, there'd be a lot of people who disagree with you. Like, I don't know enough to really have an opinion on it. But like usually when I hear people talk about like the math goats, Euler is always in the conversation. I have been weirded out by like the first time I learned about Riemann was of course with Riemann integrals. But then like his name would, and so I assumed he like mainly made contributions like in like the lower parts of math or whatever, like earlier on in math. Then his name kept on coming up with like the general relativity stuff, with like the differential geometry. It's like, man, okay, this guy did a lot. But yeah, Riemann surfaces, Riemann hypothesis, of course. Euler piano, Riemann Lagrange. Yeah. Why do we need so much theorems? That's what math is all about, the theorems. Cauchy, yeah, Cauchy has so many. Didn't he also do analytic continuation? I think so. That feels like a thing that he would do. Like, did he do the gamma function first? I I don't know. Gamma function. Oh, that's Bernoulli. Dang. And analytics mechanics improved kinetics conversation for 1 hour and a half. Jeez. Conservation. Okay. Managed everything. Algebraic geometry, Riemannian geometry, complex analysis, manifold analytic number theory, algebraic topology. Yeah. It's so, like, the further back you go in time, the more people, the more, like, fields smart people covered. Like, um, like the ancient Greeks, like, those dudes did fucking everything. Like, math, physics, political science, philosophy, like, and I feel like the farther on we've gone in time, the more narrow it gets. To the point now where, like, with PhDs, it's just like hyper specialized. Um, it's still really impressive for people who are, like, relatively recent and still manage to do so many different things though. Like, Riemann was like, what, 1800s it said? That's still pretty freaking recent. Polymaths, yeah. In algebraic geometry, we were really able to catch up with this intuition in the 1980s. Jeez. 120 years later. Also, okay, he has a really strong beard game. The hairline, oh god, he just needs to embrace being bald. It's not a good hairline. The 1800s were the best math years. Ooh, that'd be a cool conversation too. Like, what century was the best one for math? 1800s would be a strong contender because, like, Gauss was going then too, right? You make a case for, like, 14 or 1500s for like Newton and Leibniz. The Arnold principle states if a notion bears a personal name, this name is not the name of the discoverer. The Berry principle. The Arnold principle is applicable to itself. Is that common though? I feel like they're usually attributed properly. Sometimes it's like about who popularized it versus who invented it, but I feel like with math stuff that's normally named pretty accurately. 1700 to 1800. Ooh. Hey Rex. Euler, Gauss, Riemann. Well, Riemann was 1800 to 1900. 1900 to 2000 is a, yeah, I mean, the 1900s too, like Einstein and people like that. Gauss was 1800s, right? 200 years. Okay, well, name the best 1,000 years in math. What's the best millennium? Okay, Gauss is half and half at least. You could include Gauss in either. Yeah, but like in 1900s, you also had like a Neumann, and I think there's so many people who I'm forgetting. Conway, Riemann's zeta function plays a pivotal role in analytic number theory. Yeah, right. One was Euler alive. 1700s. Wait, I don't think I've seen that one of Euler. He looks like an English dude there. Yeah, like this is a pretty crazy resume right here. We should do a tier list based on dawn preference. Like I should rank who I like the most. That'd be a fun stream. I'd have to do a lot more reading, to be honest. Euler is like, as a person, he's supposed to be pretty freaking cool, right? Like, normally mathematicians have pretty problematic pasts, but as far as I know, Euler is just a cool dude. He'll probably rank really highly. That's true. I did do the bear ranking stream. Yeah, I think like Gauss, like I Gauss has like at least one dirty thing in his past. He either like he mistreated his wife somehow. I forget if it was actually like abuse or just being a jerk, but we had a professor at uni who looked exactly like Euler with a shorter modern hairstyle. Oh, that's funny. Ronald Fisher, kind of problematic. I don't know who that is. Oh God, those glasses make him look so angry. A genius who almost single-handedly created the foundation for modern statistical science. Wow. Maximum likelihood estimation. Ooh, that is huge. Did a lot on genetics. Wow. Oh, yeah, that's a bit of a problem. Uh yeah. Okay, I can see why he's problematic. Oh geez. Oh God, I would oh what a fucked up journal that must be. Such good intuitions. Geometry, algebra, analysis, topology, didn't have technology to execute all of them. Einstein cheated on his wife? Oh, I didn't hear that. Who can we consider the best current mathematician? Yeah, Terry Tao is like uh the popular choice for that. Different times? This is even for the times, that's pretty out there. Like, yeah. I'm not saying that there were a lot of people who felt that way to like even to today there's still people who feel that way, but like I think that excuse only goes so far. Oh, there's also a New Zealand cricketer named Ronald Fisher. Let's see if he's a better person. Oh, he has two sentences. No. Oh, that feels so mean. This feels like an insult to make a Wikipedia page for someone but only have two sentences on it. Like, ugh. Poor guy. I don't know. I don't know much about Terry Tao other than he made Lean. He's also the expert testimony for tobacco companies in his time to oppose smoking regulations. Fisher was. Oh, so he was, he was trying to protect the tobacco companies. Oh God. He skipped 5 grades. Wow. University level mathematics courses at the age of 9. A 760 on the math section of the SAT at 8 years old. Holy crap, dude. Tao is the youngest winner of each of the 3 medals in the Olympiad's history. Holy. Peter Scholes. Oh, that's the finance guy. Like the Black-Scholes equation or something. Oh, dude, he's got a mane. Look at that hair. Oh, algebraic geometry? Oh, fair enough. Who? But okay, there's a different Scholes that did the thing that I'm thinking of, right? I'm not that far off. Like an investigator? I don't know. It might just be that his research is like too high level for it to be commonly encountered by like even like you and I who study math. Oh, okay. Let me try to pronounce this. Jean Dudon? Complete guess. Had ranking of all the mathematicians. When Grothendieck was a student, he decided that Grothendieck was such in another league, he would stop all his research to become a human typewriter for Grothendieck? Wow. That's wild. Dieudonné? Okay. Donné? D-I-G-T-G? Okay. Good night, mouse. Oh, Scholes spelled like that. Okay, fair. God-given. Oh, that's how that translates? That's such a cool last name. Peter's probably the most one of the most influential mathematicians of our time. Huh, fair enough. His age 37? Oh, he got a Fields medal. I was about to ask that. Yeah, Mouse, when I see terms like that, math, I just kind of don't question it. Like, oh, look, another part of math that I've never heard of. That takes two very simple sounding words and I'm sure is something completely different that isn't the common understanding of arithmetic or of geometry. Bayes was in the 1700? I don't know when I would place Bayes. Oh my god, that's what he looks like? He looks like a firebender. I don't know why that's the first thing that comes to my mind. Yeah, he just looks kind of harsh. He never published Bayes' theorem. His notes were edited and published but posthumously. That's just weird word by Richard Price. That name sounds familiar. Dude, he looks even angrier. Oh my god. He's giving someone the stink eye off camera. Or off easel. Something about that sounds familiar. Cannot often be much smaller than C. What the hell? Okay, so this is the Japanese mathematician. Conjecture still regarded as unproven. Okay. Yeah, okay. Hamilton? Okay, I better say Hamilton math, otherwise we're gonna get the revolutionary or early America dude. Whatever. Hamilton math. There we go. Are there multiple math Hamiltons? There are. I'm assuming we mean the Hamiltonian mechanics Hamilton. William Rowan? He looks kind of grumpy. He's got, oh, dude, that is a 6 head. Look at that. That's not a 5 head. That's a 6 head. It's actually, it's probably just like the photo gets kind of flattened. It's probably just like the top of his head that in the photo just looks a little too flat, but. One for classical mechanical, the other for Poincare. I don't know how you pronounce that. If it's Poincare or Poincare or something, but conjecture. Shinichi Mochizuki claims a proof. Most believe it as Schultz. Another guy points to a crucial flaw in it. Okay, fair. Yeah, that I feel like I've heard of that. I don't know much about it though. Point Curry? Really? Wait. Uh he learned a dozen languages. Wow. But it's disputed. Point Carre? Hmm. The only father-son mathematicians who both got a Fields Medal? Ooh. No. My only guess would be like the Bernoullis, but they probably predate the Fields Medal. I can't think of any other like father-son mathematicians in general. Actually, did the Bernoullis even have father and son directly, or was it like two brothers and an uncle or something? Another weird name for a mathematician? Yeah. Perelman? Oh yeah, I've heard that name. I don't see anything problematic in Hamilton's Wikipedia, at least. Yeah, he's a pretty big guy too, right? Or not like physically large, but he's a big name. Oh, he was offered a Fields Medal but turned it down. Oh, he's the one who turned down the $1 million? I think I got my wires crossed at some point. Because I thought that was Grothendieck for whatever reason. Who do you think physically is the biggest mathematician? That's an excellent question, Phobos. The physically largest mathematician. Oh man, there has to be some sumo wrestler mathematician out there, right? My badass. I would have done the same. I had him crippling death. Oh no, he did also get a Fields Medal, was offered one, right? Maybe it's just true for both of them. Oh wait, he was like offered the Fields Medal at the same time as someone else, but he didn't like the other person or something. I don't remember. Grothendieck's story has way too many crazy parts to remember them all. I can't think of any mathematicians that like are particularly fat or even tall. Jean Dudon is pretty massive. Let's see. He doesn't look that. He looks kind of skinny. I mean, it's hard to tell. I need to see a full body. Oh, okay, yeah. You can see it there. Above two meters. Ooh, and 250 pounds? Okay, yeah, that's pretty big. Bernoulli family lore? Yeah, I think that they do. Oh yeah, Rex. See here? Okay, yeah. I've been working on it today, but last night I fixed my code for this problem about the northern spotted owl. And according to a study in 1988, they found that the population of owls was declining. And in this problem, we basically identify if we want to turn around the population growth and like make it so they're actually growing and not declining, at what stage of their growth should you protect them to have the most impact. And so the answer that I found for that was basically right when they start at breeding age. Because for the first 3 years, they don't breed. And then once they hit age 3, they start to breed, and they kind of produce the same amount of offspring going forward. And so we can show that mathematically. Kind of like this line here is the important one, where the higher the number in this array, the bigger the impact it has on the population growth. And so this is age 0, 1, 2, and then right at 3, you have 0.11. So if you can increase that number, you'll have the greatest impact on their overall population growth. But honestly, this is the number of offspring that they have each year, which you kind of can't really control. It's a little more productive to look at their survival probabilities, which is the second row now that I think about it. But you see the same thing, like right at age 3, they had the highest number at 0.037, and it steadily declines after that. And so that kind of indicates that you should focus on like age 3 and like 4 or 5 in like the next like few years to have the highest impact on their population growth. Hey, Jody. Grothendieck once asked a judge to receive the biggest sentence if the judge was not a coward. Really? I didn't hear that one. I do remember reading about him, like he would go to like well maybe as either when he was in Germany under the Nazis or when he was in France protesting the Nazi regime or something. I bet it was during that time of his life. Make lab owl babies. That's another option too, I guess, Rex. Geody, I'm probably gonna wrap things up soon. I'm getting pretty tired. If you want to just put your question in chat now, and if it's quick enough, I'll just do it now. Kind of caught me towards the end though. Quadratic inequalities? I don't know what that would look like. Ugh. So yeah, I haven't truly started it yet, but there's this other question about killer whales. This one feels a little more messed up though, because the question is basically asking how many whales can you kill each year while their population is still increasing. So this one feels a little cold, but I guess it's like I can feel better about it if I think about it like in terms of like ethical hunting and not over hunting them. And like the thing I particularly don't like about it is they say the word harvest, which I'm sure that's just like the scientific term for it. But like harvest sounds much nicer than hunting or killing. I feel like you're kind of glazing over what's actually happening. And also just an exercise in a textbook. We're not actually having an impact on the world. Applied math is brutal. Yep. It's a dog eat dog world here in applied math. Yeah, Judy, I'm not sure about quadratic inequalities. That sounds like something I'm probably going to get confused on, to be honest. Oh yeah, I didn't mean to click on this tab, but we've been learning about neuroscience too. We're going to be doing something with the electrical signals that neurons fire is the word that they use. And we're learning about how they like bring in enough positive ions and then close off the channel and then they shoot them out later. The Hangman game in Python? Nice, Geody. Good luck. What do people need whale for? I mean, that's like a traditional thing for some cultures to hunt. Like I always think of like Japan as like being one of the countries that hunts whales still. Connect 4, nice. But I mean, in like the 1800s, even like Britain and stuff, or America too, they would use wouldn't like the whale fat be used for lamps to make light? And I think they also just like eat the meat, I assume at least. Is physics easy? That's a bit of a vague question, I would call it. AP physics? It really depends on the person. Yeah, I'm sorry. I have a hard time answering that. 'Cause it really depends on you. It depends on the teacher. Bioelectricity is fun. Yeah, I think it'll be fun. How many terms did we need? 153. Synaptic transmission is cool. Yeah, and a really weird coincidence. In my other class that's not about biology, we had a task to simulate differential equations, or to get numerical solutions for a system of differential equations for two coupled neurons. And I thought it was really cool to get these graphs. I posted this in my Discord. So like in these last two ones, these are for like, there's 5 different graphs here because they had us vary certain parameters 5 times. But like these last two graphs are really cool, where you can see the first neuron firing, and that triggers the second one to fire, and they both decline, and then it fires again, and it's like, it's cool. In the beginning, they measured the pulse in a giant neuron. Yeah, one of my classes was talking about that. They use it in octopus neuron first. Cool guy named Artem Kirasanov goes over some neuroscience maths on YouTube. Ooh, cool. Might be worth looking at for me. Oh wait, we should use capital N instead of A. So yeah, I still have no clue what they mean with approximating values of C sub n. But G of 0.9. Oh, how do you do about equals in LaTeX? Like the equal sign with the tilde above it. I guess we can do the double tilde. That's also good. It's not slash approx. LaTeX approximately equal. It is slash approx according to Google's AI. Oh, it is. Nice. It is. Oh, yeah. I'm okay with the double one. I don't really know what the difference is, but between the symbols, to be honest. And I doubt they would care about... If there's a difference, I doubt they would care about it. Favorite YouTubers with a field medal? I don't know of any YouTubers with a field medal. I guess Terrence Tao probably has a YouTube channel, right? Slash sim is just the tilde? Why can't you just type the tilde? Oh, does that have a meaning in LaTeX? That's interesting. SimEQ? Huh. Yeah, so I'm happy with what I have here now, but it's good to know. Slash, oh, okay, fair. I slash SimEQ. I don't like that it's only one line. That bothers me. It's for isomorphism and algebra? Okay, well, that's reasonable then. Where am I? I'm here. I did some twice, didn't I? Wait, I don't want this. I'm gonna mess something up here. Ah, I did two sums. Bruh. Ugh, actually, let's get... Ah. Okay, fine. You win. Not to infinity. But to 153. Just slash... Well, I guess we can just say equal. $9.999999. Oh wait, isn't... maybe not, I don't know. Okay, that is 6 nines. Ah, haha, 6 nines. It's a good number of nines to have. $9.999999. I think some distributions of LaTeX fuck up with that symbol as Unicode that's not defined. It would expect to slash sim. Oh, okay. When I'm making markdown docs, I use tiny tech and dashes and tildes and Greek letters, and Unicode mess it up by IDKY. That's interesting. I'm working for the most sub indices in LaTeX like 4. I remember you posting about that. It's a lot of sub indices. Okay, and part E is the really weird one. Thing you're most proud of in your master thesis? Getting 4 sub indices? I respect it. Isn't this 0.9? And this should be minus 1.1. And then this number needs to change. Oh, wait. I used the wrong number. Ooh, that's like 4-0. I need to round this differently. I guess I should give the 9.99 up here. I keep saying we. It's really I obtained a value. Okay, and then what's my approximation for minus 1.1? 476190. Okay, so if you ever teach a CA course, are you going to give some funny numbers in the student homework? I don't know if I will be writing the homework, but I would be tempted to for sure. I think 69 is probably a little bit risky to include. Like I know that Penn Center, he always includes 17, right? Yeah, I think that's his favorite prime. Like whenever he does any like homework or tests, 17 is somewhere in there. Definitely did a couple of times. I respect it. Don't Kabushun Don et al. There is a paper with my name on it out there. I'm not the leading author though. Definitely not. It is very easy to find out my last name now. And so it might be fun to actually just go and talk about that paper anyway, because the paper has my last name on it, but I feel like it's not really a big deal now. So, okay, explain my results. My result um is the same as the it's not very mathy. Um it's really more of a computer science paper that just happened to have some math involved in it. I don't remember what the math component even was. Like my role was more about coding. I would have to dig it up. I'm not sure. Cause it's like it was actually it wasn't even published in a real like journal. It was accepted by a conference. Um, but apparently in computer science land, that's about as good as a publication. Um, I can send it to you though if you want. But it was basically like well, when I was doing my undergrad, I was a research assistant for a professor, and that was one of the projects that we worked on. That was the only one that actually came to fruition with a an actual paper. Yeah, I think computer science is like a lower bar because things move a lot faster. I guess that's how it was described to me. Convergence, and I have used a relatively large number of terms, 153. For undergrad, I wrote like one report paper. I can send you the English version if you want. Sure. All right, I think I should probably I want to do some cleaning up to the phrasing of this, but I think this complex analysis homework might just be done. Which is pretty pog. I should really get this onto a new page because it's just a little like stub here. How do you do that? LaTeX, new page. Or I guess page break is better. Or it's like we have two options. Directly, the page will be directly cut off and a new one will begin. I think I want new page. Slash new page. Yeah, it looks good. Thank you, K-Pars. Okay. We might call it here for the day. This feels like a good amount of accomplishment. I need to do some more work tonight, but I kind of want to get food and take a mental break here. A bit cringe to look at it after 3 years. Oh no. Our publications, it's looking through your old publications, like looking through like your old Facebook posts and cringing. I didn't really write much anything for the paper that has my name on it, so I won't have much to cringe about for my paper, but yeah, but it kind of matters. Yeah, that's true. Thank you, Rex. Yeah, this will be the end. So I'm cutting the YouTube stream off here, and I'll see you on YouTube. Thanks for being here.